So let's talk logarithms. Logarithms are a very, very important function. They're typically introduced in your first or second algebra class, and after that they're going to keep coming up just because they are something that's very important. Now, in the beginning, logarithms will seem very tricky. The reason for that is because we're going to look at some notation that you aren't used to, and logarithms have some properties that may not be completely intuitive. However, you shouldn't let that get you down because once you figure these out, they become really, really simple. They really aren't that bad. So let's first start off with when you would use logarithms, right? So logarithms are typically used to find unknown exponents. Now, we already have something that you can use to kind of undo an exponent, right? But this works for a different situation. So say you had something like this. X squared equals 25. You already know how to work with that. You would just square root both sides to find out what x is. You get x is equal to 5. But what if you had something like this? 2 raised to the x power. This time your variable is in your exponent, and that's equal to 16. Now, if we wanted to solve this, right, this you might be able to tell what the answer is because I've used small numbers. But say, even if the numbers were bigger, you wouldn't be able to take the x root of both sides to find out what x is, right? That just wouldn't work. What you do is you would use logarithms, right? And then you would find that x should actually equal 4. And this is basically what logarithms are used for. They're used to find unknown exponents. They're used to find stuff when your exponent has the variable and the base, this number down here, is a constant term, is a number you already know. So let's look at the basic form of a logarithm. Okay, so a logarithm, right, is kind of a different way of writing something in what's called exponential form. An exponential form is something you're already used to. It's a number raised to an exponent, and that equals some number. And you can convert this into a logarithmic form. And the reason you'd want to do that is for what I just stated, where you have an unknown exponent. So this is an exponential form, right? 2 to the x is equal to 16. So let's rewrite this so I get the exponent by itself, right? So in this case, your b value would be 2, your y value here is x, and your x value here is 16. And you can convert that. The way you convert it is to your logarithmic form. First, I should mention the way you should say this. The way you would say this logarithm is y is equal to log base b. That's what that number is down there as a subscript of x. Y equals log base b of x. And the way you convert it is in exponential form, the base of your exponent, right, this number down here, which would be the 2, would become the base of your logarithm. Whatever the answer was before goes inside the parentheses for your logarithm. And whatever the exponent was goes by itself on the other side of the equal sign. So let's actually look at converting this into log form, right? What you do is just first start off, okay, so logarithm, what's my base? Well, my base of my logarithm should be the exact same as the base for my exponent, which is 2. So that's going to be log base 2. Log base 2 of what? The thing that goes in here is whatever my answer was before. The answer was 16, right? That was the thing alone on the other side of the equal sign. So it's log base 2 of 16, and that's equal to whatever the original exponent was, which in this case was y. And that's how you would convert it to log form. Now, for much larger numbers, you'd typically be allowed to use a calculator. You could put this into your calculator to find out what this answer is. Now, let's just look at a couple of examples where we're converting from exponential form to log form and log form to exponential form, just to get used to what that conversion looks like. All right, so here I've written down just a few formulas in exponential form and a few in logarithmic form, and we're just going to convert, right? We're just going to get used to understanding what parts of an exponential correspond to what parts of a logarithm and vice versa, right? Just getting used to, what goes where. So let's start off here. We're going to take these exponential equations and convert them to logarithmic equations. So 3 to the x is equal to 96. How would we go about converting that? Okay, so what's important to remember is we're always going to start logarithm, and there are 3 components. We need a base, we need whatever the new answer is, and we need the thing inside the logarithm. Now, the base of your logarithm is going to be the base of your original exponent. So the base of this exponent is 3. The thing that goes inside the logarithm was whatever your original answer was, which in this case was 96. And that's equal to your exponent, right? And the way to, help remember that is just keep in mind that the reason for logarithms existing are to find exponents. So whatever your exponent was, that gets put by itself on the other side of the equal sign. All right? So I suggest pausing the video, trying doing these other 3 by yourself, and see how you do. All right? So next, again, you write logarithm. What's our base? Well, our original base is 4. What goes inside? Well, what was our original answer? 16. And what does that equal? The exponent, which was x. Similarly here, right? And I'm just kind of using these, right? These letters correspond to each other. So, how do I convert this next one? Logarithm of my original base was 12, so that's now the base of my logarithm. So I read that as log base 12 of 1,414. And that's equal to the exponent. And this last one here, same steps. Hopefully this is becoming repetitive. Repetitive is good. It means you're kind of getting used to seeing this. Logarithm, what's our base? Our base is 7. What goes on the inside of the logarithm? Well, whatever the original answer was, which is 287. And that's equal to our exponent. Okay? Now let's look at it doing the other way, right? Where we have a logarithm, we want to convert it to exponential form. So, exponential form, we have 3 key components. We have the base, the exponent, and the answer. And we just want to know what goes where. So the base of our logarithm is the base of our exponential form equation. So if 7 is our base of the logarithm, 7 goes here in the base. Our exponent was whatever our answer in the logarithm was, right? The exponent is the thing that was by itself. So this x becomes the exponent of the 7. And whatever's inside the logarithm was the answer in the original form, in exponential form. So then this becomes 2, right? 7 to the x equals 2. Now some of these might not make total sense to you. Just these are mainly for just example purposes, just getting used to the form. Now, you don't always get the actual variable in the same spot every time. So these next few examples have it in changing locations, right? So same rules still apply. What is going to be the base in exponential form? Well, that's going to be the base of our logarithm. Here I have log base 3 of x equal to 12. So my logarithm base was 3, so my new base is 3. My exponent's going to be 12. And then my answer should just be x, the thing inside the logarithm. Let's go here. What is the base of our logarithm here? Well, the base of a logarithm is x, so the base here should be x. What is our exponent? Well, the exponent should be 64. And what should the answer be? Whatever is in the logarithm of 4. What's next? Log base 3 of 5 is equal to x. So 3 is our log base, so that's going to be the base here. What's our exponent? Should be that x value there. And what's our answer? Whatever is inside the logarithm of 5. So hopefully those conversions should start making a little more sense. Last thing I want to go over is the what are called like the standard or common logarithm and what's called the natural logarithm, because those come up a lot, especially the natural logarithm. All right, so here we have two specific types of logarithms. We have a logarithm with a base of 10, and that's called the standard or common logarithm. And we have a logarithm with a base of e. Now, if you don't know what e is yet, e is a particular constant in the same way pi is. You know how pi is an irrational number that we represent by that symbol? E is also an irrational number, and it's equal to like about, I won't be able to actually write every single digit, but e is approximately 2.71828 I think 1, 8, and then that goes on forever. So e is a specific number. So when you have a logarithm base 10, that can just be written as logarithm base 10 of x, right, of a number. That can just be written as log of x, right? If you don't see a number there, you can assume that it's 10. Similarly, logarithm with a base of e, log base e of x, is always denoted as the natural logarithm, as ln of x. So anytime you see ln of x, you know that's the natural logarithm, logarithm base e of x. All right, so that should cover the basics of what is a logarithm. The next video that you should go check out if you're in the logarithm unit is common properties of logarithms, where I go over how to do certain operations with them, how you deal with multiplication and exponents within logarithms and things like that. All right, if you have any questions in this video, leave it in the comments down below. Hit the like button if this helped you out. And other than that, good luck, guys.